Okay, next is the tertiary treatment. So tertiary treatment, or called as an advanced treatment, or sometimes also called as a chemical treatment. Jadi untuk secondary is the biological, so tertiary ataupun advanced, ataupun kita akan tambah chemical lah. Saya ingat saya tulis. So secondary treatment process coupled with this infection may remove over 85% of BOD and suspended solid. So from this advanced treatment is needed to remove the all around to 99% of BOD and suspended solid. So only minor removal of some pollutants such as nitrogen, phosphorus and soluble COD and heavy metal is achieved. So from this advanced treatment, this can be achieved. So process capable of removing pollutant which is not adequate removed by the secondary treatment is called tertiary treatment. It may improve the effluent quality to the point that is adequate for many reuse purpose. So antara contoh tertiary treatment kita ada filtration, carbon absorption, phosphorus removal, nitrogen removal. So untuk filtration biasanya this process is similar used in the wastewater treatment. Filtration maksudnya kita just filter lah. So dia akan remove suspended solid and microorganism, and sometimes also commonly use sand filter. Ni yang biasa digunakan lah, tapi dia akan menyebabkan clogging. So the problem is presence of small particles that are too small to be removed by settling. So kadang-kadang filtration pun ada masalah sebab kita nak removekan yang lagi kecil punya particles tu menggunakan kaedah settling ni susah lah. And then attached to this particle can be organic, chemical or metal. Terutamanya kalau metal memang sangat susah nak di remove menggunakan kaedah filtration. Okay, this is the example of the filtration process, which is using the reed bed filtration system process. So there is reed and rock as a filter media. So the water will come to this pipe, and then the smallest particles, then this rock can be passed through, can be passed. However, in the outlet phase, the smallest sand particles can pass through the wastewater stream. So kalau yang lagi besar tak boleh dah lepas ke sini. Kalau dia kecil dia boleh lepas. Okay, so ni adalah konsep filtration. Okay, next is the carbon absorption. So soluble organic material that are resistant to the biological breakdown may persist in the effluents called refractory organic compound. So it can be detected in the effluent as soluble COD. So kalau macam carbon absorption ni, biasa kita boleh remove COD. So carbon absorption is the most practical available method. Ni memang sangat biasa digunakan. Student pun selalu guna. So carbon ni biasanya kita akan menggunakan carbon activated carbon. So ni projek yang biasa student akan gunakan. Activatekan carbon maybe from the rice husk ke, itu yang baru-baru lah. Kalau yang biasa dekat industri memang biasa dia guna yang commercial activated carbon. So this activated carbon will be heated in the absence of oxygen about 1500 degree Celsius. Dan bila dia dah jadi activated carbon, barulah dia boleh melalui proses adsorption, okay, to remove the COD, BOD and suspended solid. Okay, so ni contoh activated carbon lah. So kalau awak buat rice husk tak jadi hitam macam ni, belum jadi activated carbon sebab kita belum panaskan dia pada suhu 1500 dekat dalam furnace. Okay, next is the phosphorus removal. So the presence of phosphorus increase in nutrient and organic substance. So overstimulation in growth of algae and aquatic plants. So phosphorus pun tak bagus bila dia terlalu tinggi, sebab dia boleh menggiatkan lagi pertumbuhan algae. So bila pertumbuhan algae ni bertambah, jadi dia akan memberi kesan kepada aquatic life. So usually for the phosphorus removal, dia akan tambahkan ferric chloride, alum dan juga lime. So penambahan ketiga-tiga chemical ni, tiga-tiga chemical ni dia akan remove the phosphorus through the chemical precipitation salts. Okay. Okay, so kenapa phosphorus tak bagus tadi? Ni pun antara punca kalau phosphorus tinggi, iaitu eutrophication of the water. Nampak? Bila pertumbuhan algae terlalu banyak, so oksigen tak boleh masuk dalam water. Okay, so oksigen tak boleh masuk, apa akan berlaku? Haiwan dekat dalam water tak boleh nak dapat oksigen, tak boleh hidup. Okay, next is the nitrogen removal. So nitrogen in an insoluble form is a nutrient and need to be removed from wastewater to help control algae growth. Sama. Nitrogen and phosphorus is a nutrient. So this nutrient kalau terlalu banyak, dia akan menjadikan pertumbuhan algae yang terlalu banyak. So bila algae terlalu banyak, so dia akan jadi toxic to the fish and also mengurangkan oksigen dalam air. Okay, so removal can be accomplished by either biological or chemically. So kalau biological process namanya adalah nitrification, denitrification. Chemical process adalah ammonia stripping. So for this chapter we'll only cover on the biological process. Nitrification is the conversion of ammonia and ammonium to nitrate nitrogen. So dia akan jadi nitrate nitrogen. So the nitrification is a two-step process. First is convert the ammonia and ammonium when the pH of the wastewater is acidic or neutral to the nitrate. Then the second one, convert the nitrate to the nitrate. So dia ada dua proses. Pertama, ammonia dan juga ammonium jadi nitrate, nitrate jadi nitrate. So denitrification is the biological reduction of nitrate to the nitrogen gas by the facultative heterotrophic bacteria. So heterotrophic bacteria ni need a carbon sources as a food. Heterotroph tadi kita dah cover kan. So dia memerlukan carbon sources as food to life. So facultative bacteria can get their oxygen by taking dissolved oxygen out of the water or by taking it off the nitrate molecules. So untuk facultative bacteria. So denitrification occurs when the oxygen level are depleted and nitrate becomes the primary oxygen sources for the microorganism. So namanya denit kan, jadi dia membuangkan nitrate tadi ni, and then dia form nitrogen gas. Okay. Okay, next is the this is the consideration. So this is also important. So the consideration of factor we need to consider to build the wastewater treatment facilities in the plant or in the industry. So the first one is the cost, including capital cost and also the operation and maintenance cost, and the availability of the space. So macam kalau kita nak buat wastewater treatment plant kat satu industri, kita pun kena tengok juga space itu cukup ke tak. Sama ada berbaloi kita membina plant kat situ ataupun kita hantar wastewater kita kepada tempat yang tertentulah yang boleh treatkan kita punya wastewater. So this is the consideration of factor need to consider before we build the wastewater treatment facility in the industry. That's why not all the industry have the wastewater treatment plant. And then the degree of the treatment required by DOE permit. Contohnya memang kalau macam contoh kilang dye, kilang apa macam kelapa sawit, yang kita tahu dia punya wastewater is a high strength wastewater. So memang dia memerlukan wastewater treatment plant untuk achieve the requirement by the DOE. And then ketika 4 municipal plus industrial. So kena tengok pula sama ada dia hanya municipal wastewater ataupun municipal with the industrial wastewater. And then kena tengok pula dia punya flow rate. Macam mana flow rate dia? Kalau terlalu sikit, tak perlulah nak kena sampai buat plant. And then distance from the resident properties. So ni kita kena cari juga, kalau kawasan kilang tu dekat dengan perumahan, kita nak buat kita punya wastewater plant tu sebelah rumah orang tu, memang tak boleh lah, sebab ada masalah-masalah lain, bau kan, lalat, bunyi bising lagi. So kena consider lah. And then agriculture usage of land application option. Sama ada contoh macam kilang kelapa sawit, mungkin dia tak boleh, dia kena ada, tapi mungkin dia kena reducekan dia punya usage of wastewater punya plant, disebabkan dia pun ada kawasan yang diperlukan untuk menanam kelapa sawit tu. So dia kena consider lah kedua-duanya tu. And then the presence of pathogens and experience of design engineer. So ni semua adalah consideration of factor yang kita perlu ambil kira untuk membina wastewater treatment facilities in the industry. Okay, that's all.